we'll continue our discussion on light with ionizing radiation. Now, if you remember in the past section, we talked about ionizing radiation. Specifically, we introduced the idea that only ultraviolet light, X-rays, and gamma are capable of being classified as ionizing radiation. So the question is what exactly does that mean? Well, we have another equation to look at, and this equation was figured out a long time ago. We've got E equals hc over lambda. And this is really just a different version of the same equations we had looked at before relating frequency and wavelength, but now we're looking at it and we're relating energy and wavelength. Remember, I've introduced this idea before that energy and wavelength, or frequency and energy, go hand in hand. What it means here is that we've got a direct relationship between the energy of light and its wavelength. Specifically, the shorter the wavelength, X-rays and gamma rays being the shortest, the higher the energy. So X-rays and gamma rays have the highest amount of energy. Now, what makes ultraviolet, X-rays, and gamma rays ionizing radiation? Well, if we look at this second diagram here, we see that ionizing specifically refers to the fact that it can create ions. These types of light have enough energy that they can actually hit an electron and knock that electron out of the orbit around its nucleus, thus leaving an ion in its place. So what effect does ionizing radiation have on the body? Well, if we look at it, we can see in just a matter of seconds that we can break strands of DNA and cause oxidative damage. Now, oxidative damage is something that not a lot of people have heard of. Oxidative damage is what causes aging. It's what causes your eyes to go bad with time. It causes oxidative stress in the heart, which leads to heart disease and so many other factors. In minutes, you get a cellular response of the body. Your body starts expressing the DNA differently. In hours, your cell functions begin to change. You start to get cell death. You start to get instability of your genome, meaning that your chromosomes are literally starting to fall apart. After days or weeks of exposure to ionizing radiation, you start getting symptoms of organ failure in the worst case scenarios. Long term, many weeks or years, you can get cancer, birth defects in your children. The gene pool gets altered permanently. So ionizing radiation does all of this because those ions that it creates and the extra electrons that it creates, those have the ability to react with your DNA, to react with your cells. They're very, very reactive, and so they do this very rapidly. As they react with your DNA and your cells, typically your body can repair it. It's this prolonged exposure, seconds, minutes, hours, days, weeks, years. This prolonged exposure to ionizing radiation can have long-term effects. Now that's for ultraviolet light. We've got the UV index, which is something that most people in California are very well aware of. Other parts of the country, maybe they don't worry as much, but here we get a really, really high UV index about half of the year. And that UV index gives us an idea of how strong, how much ultraviolet light are we being exposed to each day. Now, that UV index is only part of the story. Our other forms of ionizing radiation, X-rays and gamma rays, are more powerful, which means they don't need weeks or years of exposure to lead to these worst case scenarios. For X-rays, just minutes to hours of exposure can lead to cancer. For gamma radiation, just seconds of exposure can lead to death, depending on how powerful, how intense the gamma radiation actually is. So ionizing radiation, just generally speaking, is bad for you. It can lead to some really bad things. Now the question is how much ionizing radiation are we actually exposed to? If we look at the total exposure in a typical year, the reality is that we're not actually exposed to much. Half, or more than half, of all the ionizing radiation we're exposed to comes from radon that's in the ground. We can't do anything about that. Now, you never hear anyone talk about the radon in the ground, so maybe it's not that big a deal. And the reality is that it's really not. We think of ultraviolet radiation and stuff coming from the sun as being bad stuff, but if we look, cosmic radiation only accounts for 8% of our ionizing radiation exposure. Everything else comes from the world around us. How much total is it? Well, we're exposed to less than 0.005 sieverts per year. Now, sievert is just a unit used for measuring radiation exposure, and you don't really need to understand how much a sievert really is. All you really need to know is that 0.005 sieverts per year or less is not a lot. And this is just your typical amount of exposure for an entire year. This amount of exposure leads to 0 medical problems. It leads to 0 cancer. Maybe in the most extreme cases, with a little bad luck, a little bit of chance, and some genetics working against you, this can cause some problems. You need 1 to 2 sieverts of exposure just to start having a 5% chance of causing issues that can't be treated by medicine. 8 to 10 sieverts, so thousands of times more than this 0.005. 8 to 10 sieverts is what it takes to really guarantee that you're going to die. Now, are we in the clear then? As far as ultraviolet goes, yes. As far as the ionizing radiation from other sources goes, yes. So let's talk about that ultraviolet. We're in the clear if we are exposed to typical amounts. Now, what are those typical amounts? Well, let's talk about the ultraviolet, the different types. We have 3 types of ultraviolet: UVA, UVB, and UVC. And they differ in wavelength, UVC being the shortest wavelength, UVA being the longest wavelength. They also differ in their ability to penetrate the atmosphere. UVC is the most powerful because it's the shortest wavelength, but all the UVC is blocked by the atmosphere, so none of it gets to us. Literally none of it gets here. UVA is the least powerful, but it is able to penetrate the atmosphere very, very well. UVB is right in the middle. It's medium level of power, and some of it's able to get through. How much? About 95% is UVA. 95% of the ultraviolet light that gets through the atmosphere and makes it to us is UVA. The other 5% is UVB. What that means is that UVB essentially is, based on the amounts that are actually getting to us, is not doing any harm to us at all. UVA also not doing any harm because it's much lower power, but its exposure levels, the amount we're actually exposed to, is much higher. So we have to be a bit more careful with it. Prolonged exposure of UVA, even though UVA is the least powerful form, we're exposed to a lot more of it total, and so we can prolong that exposure for hours very easily in a single day. The other difference between UVA and UVB, UVA has the ability to penetrate our skin to deeper layers. Specifically, it has the ability to penetrate to the layers where we have stem cells and stuff like that, which means that the ionizing radiation in the form of UVA has the ability to have more of an effect on our body. UVB doesn't penetrate as deep. It comes in contact with fewer living cells, which means that even if we are exposed to more UVB, because it doesn't penetrate as deeply, it's not going to have as great an effect on our body. Now, in some of the worst areas on the planet, you only get about 180 days out of the year where you really have to be worried about UVA or UVB exposure levels. But on those 180 days, you really have to worry about UVA and UVB exposure. What about gamma rays and X-rays? Well, the biggest source of these are actually coming from the ground, different radioactive elements and whatnot in the earth. The sun is actually a fantastic source of gamma rays and X-rays, but as we see here, gamma rays and X-rays don't make it to don't make it down to us. Most of the ultraviolet doesn't either, but the little bit that does, this section right here, that's the UVA. So gamma rays and X-rays mostly blocked by the atmosphere, and we'll talk about how that happens later. Now in part 4, we'll talk about protection and repair. So let's say we are exposed to ionizing radiation. How can we protect ourselves from the damage that it can cause? And then what if it does do damage? How can we repair that damage? Well, it turns out our body does quite a bit to prevent that damage, and then if damage does happen, to repair that damage. Very simple mechanism that most people are very well aware of. Tanning. This is our body's way of protecting us from ultraviolet radiation. As ultraviolet enters the skin, penetrates deep down to the living tissue, our body responds to that by producing a protein called melanin. And that melanin blocks the ultraviolet light from getting through again. The advantage of that is that it prevents ultraviolet light from penetrating any deeper, and that prevents the majority of the cells from being exposed to ultraviolet light, which means no damage from the ionizing radiation. Now, tanning can be done in multiple ways. It can be done over a slow, long period of time, and that's the healthy way of doing it. The rapid tanning that some people do, where you try and expose yourself to a lot of UV very rapidly and you tan very quickly, your body takes time to produce that protein. So those high levels of ultraviolet exposure in very short amounts of time do a lot of damage. And that's when you start running into problems. Now, something else to consider is that this melanin production, this tan, doesn't stop all the ultraviolet light. The more tan you have, the more ultraviolet light you stop, but you're not stopping all of it. And on top of that, you still have living tissue above the melanin producing cells that can be exposed and therefore damaged. Now, antioxidants. This is another thing that our body does to prevent the ionizing radiation from damaging stuff. Ionizing radiation creates ions by removing electrons from atoms, while antioxidants give that electron right back. We have several natural occurring antioxidants in the human body, specifically vitamin E and vitamin C. These are the two big ones. There are other antioxidants that we can get from food sources and that our body makes naturally, and we'll talk a little bit about that at the end of this section, but the reality is that the evidence isn't conclusive on whether adding all these extra antioxidants are actually helping. The fact is that our body has a lot of this built in already. We don't really need to add a lot more. Now, repair mechanisms. Our body is capable of repairing the DNA when it's damaged. The issue comes up when we damage our DNA too quickly. Prolonged exposure is the big issue. Our body can repair most of the DNA damage, but it takes time. If we cause damage faster than what it can be repaired, that damage will linger around and end up leading to DNA mutations, cellular problems, and eventually tissue problems. Worst case scenario being cancer. Now, the atmosphere prevents a lot of our exposure from ionizing radiation, and we saw this slide in the last section. The majority of the ionizing radiation, ultraviolet, X-rays, gamma rays, never even makes it to us. So the atmosphere is doing us a huge favor. How is that doing that? Well, the oxygen and the ozone in the atmosphere are the key. Oxygen, that's 2 oxygen atoms bound together, and ozone, that's 3 oxygen atoms bound together, contain bonds. These covalent bonds are capable of absorbing this energy from the ionizing radiation, and then the energy dissipates in that way. So the ozone is actually doing a really good job. The atmosphere in general is doing a really good job of blocking this ionizing radiation from getting to us. What can we do to help? What are some preventative techniques that we have? Well, sunscreen is the number one. Sunscreen, there are a lot of different chemicals out there that are capable of absorbing or repelling UVA and UVB. We don't need to worry about UVC. It doesn't get to us, but there are sunscreens out there that are capable of blocking UVC. The issue is that a lot of people, Americans specifically, are really bad about applying sunscreen in the way that it's supposed to be applied. You're actually supposed to apply quite a bit, and you're supposed to do it every hour if you're swimming, every 2 hours if you're not. So in a typical large container of sunscreen, that might be 1 or 2 days worth of beach time. Most Americans only go through 1 container every summer, so we're definitely not applying enough, which means we're not getting the level of protection that we should be getting. Now the recommendation is SPF 30, that's sun protection factor 30, but with the amount that Americans use, the recommendations jump up to SPF 110. So we should be using SPF 110 in the amount that we use it. Now that can get really, really expensive, but so can treating cancer. So you got to weigh your options there. I would say going with sunscreen is probably the cheaper option. Also, other than sunscreen, we can pay attention to the UV index. Now the UV index oftentimes shows up in a chart like this, and oftentimes there are suggestions in this chart on what we should do to prevent exposure to that level of UV. For instance, in a UV index of 3 to 7, maybe you want to stay in the shade during the midday hours when the sun is its most intense. Put on a shirt, use some sunscreen, use a hat, maybe even some UV protective sunglasses. If the UV index is 8 or above, maybe you don't want to be outside at all when the sun is high in the sky. Shirt, sunscreen, and hat are absolutely a must, and always protect your eyes with sunglasses. Now, one last way that may be useful for us to help prevent damage from ionizing radiation is to actually consume antioxidants in our food. Now, the evidence is a little bit sketchy on this. There's some studies that show that absolutely this works. There's some studies that show that maybe it doesn't. But there's one thing that's absolute. All the studies show that there's certainly no harm in trying. Eating healthy foods in a variety of colors. Most antioxidant-rich foods are going to be very bright. They're going to be green, they're going to be yellow, orange, red, purple. Eating a variety of these types of foods puts a lot of different antioxidants into our body. And those antioxidants could help fight off cancer, which is what most people are focused on. But the reality is those antioxidants, while maybe not helping with the ionizing radiation, the verdict's still out on that, they are helping with a lot of other things. So they certainly are helpful in keeping our body healthy. How helpful? That's the big debate right now. Do we really need them? Also part of the big debate. But like I said, there's certainly no harm in trying.